Hello guys, today we'll going on the numerical. Okay, I will read the numerical and what is the given data I will tell you. See, one cantilever beam is given. The beam having the 60 mm wide, 60 mm wide. Means which dimension is given? D is equal to 60 mm and depth is given 100 mm. D is equal to 100 mm. Means rectangular beam is given. Okay. And cantilever beam 2 meter long, length is given 2 meter and UDL value is given 3 kilonewton per meter over a entire span. Compute the magnitude and location of the maximum flexural stress. What we want to calculate in that? We want to calculate the maximum flexural stress. Okay. Also, determine the type and magnitude of stress in fiber 20 mm from the top. Okay, 20 mm from the top. We want to calculate the fiber value. Okay, this 20 mm from the top. We will check that from the beam at the fixed end. Okay, we want to calculate the magnitude and stress. Again, we want to calculate the stress at the top from the 20 mm. This is the given. We know the formula. Okay, there is only one formula. This is the bending formula. You have to remember that formula. M by I is equal to sigma by Y. Okay, remember that formula. M by I is equal to sigma by Y. What we want to calculate? Maximum flexural stress induced in the given beam when the UDL is act on the given beam. Okay, sigma max. Also, we want to calculate the maximum flexural stress induced in the beam from the top to the 20 mm depth. Okay. We want to calculate that position, that maximum flexural stress. And how to calculate that? What will require? Will require the bending moment first. Okay, remember the steps. How to calculate that? First is a bending stress. It is denoted by the M. What is the maximum bending stress for the given cantilever beam? We have seen already in the unit number 3. Right? This is the standard condition is given. Check that. There is a, we'll consider the W is there. W is there. And this distance is given L. And what is the moment? If you have taken the moment, then you will get W into L is there. And you convert it to the point load into L by 2 is there. Where is that? At the half distance. Half distance. Then you will get the standard formula WL square by 2 is there. WL square by 2 is there. You have to remember the standard condition from the unit number 2 when you solving the numerical on bending moment. Okay. Then put the value. What is the value of W? W is equal to 3 kilonewton per meter. Then L is equal to 2 square divided by 2. You will get what? This to get cancelled 6 kilonewton meter. Okay, M is equal to, if you have converted to the Newton mm, then which value you will get? M is equal to 6 into what? Kilo. Kilo means what? Again 10 raised to 3. And here is the meter is given. We want to convert into the mm. Means 1 meter is equal to 1000 mm. Again 1000 means what? 10 raised to 3. Means directly I will write 10 raised to 6 Newton mm. Okay. You will get the first value. Moment of resistance is equal to 6 into 10 raised to 6 Newton mm. Then we want to calculate the neutral axis position. This is denoted by the Y. Second point is a distance from the top, or we can say the bottom, to neutral axis. Neutral axis. Okay, it is denoted by the Y bar. How to calculate that Y bar? This is the symmetric. That's why you will get that the center. You can directly write the d by 2. We have seen before lecture. Okay, previous lecture we have seen y1 is equal to d by 2. Okay, what is the total depth? 100. 100 divided by 2, you will get the 50 mm. 50 mm. All of you getting? You have to calculate the neutral axis position, because here is a only one component is given, rectangular component. Okay, at the half distance there is a centroid of that component. This is the 100 by 2 is there. Third, we want to calculate this. We want to calculate the moment of inertia. Moment of inertia. Third is a moment of inertia. It is denoted by the I. What is the moment of inertia for the rectangular body? We have seen in the section modulus. I is equal to what? BD cube divided by 12 is there. What is the value of B? 60. What is the value of D? 100. Cube divided by 12. If you are solving this, then check that you will get the 5 into 10 raised to 6 mm raised to 4. Okay, this is the third value. Then directly you can calculate the maximum stress. We know all the value. M is known, I is known, Y max is known. Okay, then what is the value of sigma? Then what is the value of sigma? Check that. I will write the bending formula. This is the M divided by I. Next step, bending formula. Bending formula. M by I is equal to sigma by Y. Then put the value. We want to calculate the sigma value. What is the M? 6 into 10 raised to 6. Why will you convert? Because all value will get in the mm. That's why I have convert meter to mm. Remember that. Then what is the value of that I? 5 into 10 raised to 6 is equal to sigma max divided by what is the value of that? Y is equal to 50 is there. 50 is there. Already we have calculated that value. Okay. And what is the value of sigma max? This one 10 raised to 6 get cancelled. Then this you will get the 60. Yes, 60 Newton per mm square. That's the maximum bending stress are induced from the given cantilever beam. If you apply the 3 kilonewton per meter load on that cantilever beam, then there is a maximum bending stress is induced 60 Newton per mm square. Okay, all of you getting? Where will get the maximum bending stress? At the neutral axis. Okay. Then when you calculate, they have given the one more condition. We want to calculate the flexural stress from the top to the 20 mm. 20 mm. Then how to calculate that? We have already calculated all the value. Check that where is the position of that 20 mm is there, no? Yes, check the position. I will take the half section of that. Okay, suppose here is a half section. This value we have calculated the 50, right? And we want to calculate, and this value is a B is given 60. Then next take that this one, this is the bending stress distribution diagram, right? Where we want to calculate, here we want to calculate the sigma C. This value is a 20 mm, and from this value we will get at the bottom of that remaining value what? 50 minus 20 will get the 30. Will get the 30. When you calculate from the top this 20, then what is the value of y? What is the value of y? Y is the outermost distance from the neutral axis. Outermost distance from the neutral axis. And which is the outermost distance, maximum distance? Say from the top we have the 20 and from the bottom we have the 30. Then we get the 30 mm. only you have to put the value in that equation again. M by I is equal to sigma by y max. Then check that m is equal to what? 6 into 10 raised to 6. What is the value of I? We have calculated 5 into 10 raised to 6. Then what is the value of sigma max? We want to calculate that sigma max at that position. Okay, what is the value of 30 is there. If you have calculated this, you will get the sigma max at that position is 36 Newton per mm square. Okay, remember that. Now take the outermost value. Don't consider the here. Don't take the 20 mm. You have to consider this value because at the neutral axis, above the neutral axis, or you should take the below the neutral axis because the symmetric figure. Okay, because of symmetric figure. If you have drawn the stress distribution diagram, take that we get this stress distribution diagram, right? Here above that we get the compression tension, right, for the cantilever beam. We have seen already nature of the cantilever beam, where we will get the sigma c or where we will get the sigma p is there. Okay, already we have seen in the last lecture. Are you getting how to solve the numerical? Similar way, if you have given the T section, if you have given the circular section or triangular section, then how to solve, how to calculate the maximum bending moment, or how to calculate, sometimes